So you might want to write down these steps. We're going to be solving root and we're going to be solving square root and radical equations. Luckily for us, it's going to be pretty easy compared to some of the lessons we've seen, only because our brains are pretty developed and we're really good at math. So this is your steps. These are literally steps, and here's why these are so nice. Everybody listen. Here's why these problems are so nice. You follow these steps every single time, and that's all you have to do. Okay, so here we go. Write down the steps quickly. First, isolate the radical completely. That means get the radical completely alone on one side of the equation. So nothing can be added or subtracted to the radical. Nothing can be multiplied or divided to the radical. So you'll isolate the radical completely. Then second, we'll undo the radical using the correct inverse. So we're going to get rid of the radical. What undoes a square root? A square. What undoes a square? Square root. And then third, you're going to solve for the variable. You might be solving a linear equation or a quadratic equation at this point. We can do both. And the nice thing is, guys, if we ever get down to ones when we're solving and we have to solve a quadratic, it will be solvable by factoring and usually quick factoring. So it's going to be pretty nice. And then our fourth step, just like when we were solving rational equations, we have to check for extraneous solutions. Now this won't be like rationals where most of them didn't have extraneous solutions. A lot of these will when we get to the advanced ones, because we're going to be manipulating these so much, it's going to introduce extraneous solutions. So remember, we just check our answers by plugging them back in. All my examples are coming off your worksheet. You got it last time, 4-3, so make sure you have that out. 5-3, make sure you have 5-3 right now. You have 5-4 on your desk, a lot of you, which is correct. We're going to try to get through both. Okay, so here we go. Does everybody have the steps written down? Can you take a picture? Yeah, quickly, take a picture. Okay, here we go. First example. Solving number 1. So it says 5 square roots of x plus 2 equals 12. Get out some paper. You're going to need major room. So here we go. What's our first step? Isolate the radical. That means get the radical completely all by itself using algebra and the correct algebra. Here we go. My first step would be to subtract 2. Everybody good? Not yet? So the first step is to isolate the radical. So if you can't write and comprehend at the same time, then just watch, if that makes sense. And then I'll let you practice, and then you can try it, okay? So if you can't do both, just watch. So we isolate the radical. So our first step, you've got to do it in the correct order. You can't divide by 5 first. That would be wrong. The first step is subtract 2. Everybody good? So we have 5 square roots of x equals 10. My next step, you have to have our radical isolated completely. My next step, 5 is multiplied to the square root of x. What undoes multiplication? So we're going to divide both sides by 5. 5's divide out. We have the square root of x equals 2. We've isolated the radical. Now we need to go to our next step, which is undo the radical. What undoes a square root? Square. So we're going to square both sides of the equation. Over here, root cancels out with power. We have x is equal to 4. There's our solution. Pretty easy, right? So what we do is check it. Watch me check it. Here I go. I plug it into the original. 5 times the square root of 4 plus 2 equals 12. I'm checking it. 5 times 2 plus 2 equals 12. Isn't the square root of 4 2? 10 plus 2 equals 12. 12 equals 12. Isn't that a true statement? So we keep it. It's not extraneous. Okay, next problem. Like I said, if you can't write and comprehend at the same time, just watch, and then you'll get a practice. Number 4, first step is isolate the radical. Isn't the radical completely alone? Perfect. So now we'll undo the radical. What undoes the square root? Square both sides of the equation. Root cancels out with power, leaving me with 2x minus 5 equals 49, correct? So now we'll solve for x using algebra. So add 5 to both sides. 2x equals 54. Then we'll divide both sides by 2. What is 54 divided by 2? 27. You're right. Now let's check our solution. Watch me check it. Square root of 2 times 27 minus 5, all under the radical equals 7. So somebody calculate what's 2 times 27 minus 5. Okay, so we have the square root of 49 equals 7. 7 equals 7. So it does work. So pretty easy, right, guys? Okay, let's do number 6. First step, you've got to go in this correct order. First step is isolate the radical completely. So my first step would be to subtract 5. So we have the square root of 5 minus 2x equals 7, right? Then we would square both sides again. So we have 5 minus 2x, because root cancels out with power, equals 49. Now, do the correct algebra. Good, very good. We look from left to right. Subtract 5. Negative 2x equals 44. Then we'll divide both sides by negative 2. Yep, x equals negative 22. So then we would check it by plugging it back in up here. We have the square root of 5 minus 2 times negative 22 plus 5 outside. The plus 5 is outside equals 12. So we have the square root of 5 plus 2. Negative 2 times negative 22 is positive 44, right? Plus 5 equals 12. So that's square root of 49 plus 5 equals 12. So that's 7 plus 5 equals 12. 12 equals 12. Was that too fast, or you guys I'm just showing you the process here. That is true. So we keep it. Yeah. Check it. Yeah, you'll need to check every single one of these. Yep, okay, so everybody, next one that's not a square root. Here we go. Everybody watching, you don't have to write it down as long as you're watching, because I'm sure you're comprehending it. First step is isolate the radical. So when we add 4. So we have the cube root of 13x minus 1 equals 4. Next thing, undo a cube root. What undoes a cube root? A cube. So we're going to raise both sides to the third power. Root cancels out with power. 13x minus 1 equals, what's 4 cubed? 64. Now it's just algebra solving for x. So we'll add 1. So 13x equals 65, right? Divide by 13. X equals, what is it? 5. And then we would check this one. So we would type in the cube root of 13 times 5 minus 1 in our calculator. Oh, yep, and then minus 4, does that equal 0? So cube root of, what's 13 times 5? 65 minus 1 is 64, minus 4 equals 0. Cube root of 64, you do it in your calculator. Do you remember how to type that in? So you get 4 minus 4 equals 0, 0 equals 0. That's a true statement, so it's not extraneous. All right, do 1 through 12, ready to go. Remember something, everybody watching. If you have a rational exponent, x to the 1/3, isn't that the exact same thing as the cube root of x to the first? Yeah. Yes? Okay, so look at number 13. We're looking at, even though it doesn't look like a radical equation like the ones above, it's actually the exact same thing because we have a rational exponent. So what you're going to do is the exact same thing as we just did above, but our first step will be rewrite it as a radical. Does everybody understand? So this is the roots go on bottom. Remember the picture of your flower, right? This is the cube root of x minus 2 to the first power equals 5. And now it looks no different than the ones above it. So now we will continue to solve it. So our first step is to isolate the radical. Isn't the radical isolated? Then we'll raise both sides to the third power. Root cancels out with power. So we have x minus 2 to the first, which is just x minus 2. And that equals 5 to the third. And then we are going to add 2, correct? Add 2. So we get x is equal to 127. And now we'll check it. You can plug it in. Let me show you exactly how you can plug it in. Go back to the original. You'll type it in like this. So we're doing 127 minus 2 to the 1/3 power. Does that equal 5? So you can literally just type it, that exact thing into your calculator. Like, just type it in. You get 5? So 5 equals 5. So that is a true statement. So it's not extraneous. So we'll keep that solution. Questions on that? Do another one. Number 15. So let's first say to ourselves, oh, we know how to solve this. Now look, it's an equation. There's an equal sign. So we're going to solve this by first rewriting it as a radical. So careful though, you got to rewrite it correctly. Isn't 2 not under the radical? 2 times x to the 3/4, correct? So that would be 2, and then what root is it going to be? Fourth root of x to the third equals 16. Okay. So now our first step is to isolate the radical. Get the radical all by itself. Nothing multiplied to it, nothing added to it. So what should we do first? Good. Divide both sides by 2. So we have the fourth root of x to the third power equals 8, correct? Now your next step is to get rid of the radical. So we'll raise both sides to the fourth power, correct? Okay, so we'll raise both sides to the fourth. So 8 to the fourth power is, so root cancels out with power. X is 8, x cubed equals 4,096. And now to get rid of the third power, what do? Cube root. Very good. So now we're just going to cube root both sides of the equation. Cube root. Now don't cube, this is where you got to be careful. Don't cube roots only have one answer. Odd roots only have one answer, but wouldn't the square root have 2? Yes. Remember, square roots, so when simplifying, I say find all the roots, we're finding all the solutions. So you have to put plus and minus if it's an even root. But it's an odd root. It's an odd root, so we don't need it. So everybody type in your calculator. Go to, perfect. So we get x is equal to 16. Perfect. We could check it, so we would type it into our calculator like this. 2 times, we got 16 raised to the 3/4 equals 16. So you could type that into your calculator, and it works. 16 equals 16, so it's not extraneous. Pretty easy. So let's look at 17. First step is to rewrite it as a radical. So notice, this piece is the square root of x to the first. Then we have minus 5 equals 0. Okay, first step is isolate the radical. We'd add 5. So square root of x equals 5. Now we've got to undo the square root. So square both sides. So x is equal to 5 squared is 25, and that's it. So now we would check it. We would say 25 to the 1/2 power minus 5 equals 0. So that's 5 minus 5 equals 0, and that is a true statement. So it's not extraneous. No, extraneous is if you plug in, check the original, and you don't get a true statement. Then it wasn't a true solution. Even though you did the math right, it didn't come out a true solution. We haven't seen any yet because on the easier ones, like the ones we've done so far, we haven't done enough manipulation to get extraneous solutions, but we're about to get to the ones that have them. And they're not any different, there's just more going on. Does that make sense? Because we're taking and changing the problem, you know what I mean? But we just check them. And so if we checked it and got 5 equals 2, that would be an extraneous solution, so we cross out, it's not a solution. Yeah. You'd say no solution if there's no solution, if there's only one solution. Well, we'll get to some extraneous ones. Okay, next example, yeah. Just keep going with me and see if it's good enough. Okay, 23. So first step, careful here. We've got to rewrite this as a radical equation. So looking at this piece, what's my root? Cube root of, and you got to put parentheses, x minus 2 to the second power. And then we have our minus 4 equals 5. So now our first step is to isolate the radical. So we'd add 4, correct? Cube root of x minus 2 squared equals 9. I've added 4. Now we're going to undo cube root, so we cube both sides, correct? Cube, cube, sweet. Root cancels out with power, so we have x minus 2 squared equals, make sure you don't say 27, it's not 9 times 3, right? 9 raised to the third power is 729. Now my next step is to undo the square. What undoes a square? Square root. So we're going to square root both sides of the equation. Root cancels out with power. So we have x minus 2 equals. Now careful. Doesn't the square root of 729, square roots don't have plus and minus answers when I'm finding all of the roots. Even roots need plus and minuses, correct? So take your calculator to the square root of 729. 27. So we've got to put plus and minus 27. Does everybody understand? So now what you're going to do is split it up. We have x minus 2 equals positive 27. And we also have x minus 2 equals negative 27. Solve for x in each case. So when I add 2, So we have x is equal to 29. There's one of our solutions, but we'll check it in a second. And then we're going to add 2 over here. Add 2. X is equal to negative 25, correct? Okay, so never assume that they're going to be opposites of each other because they won't be. Does that make sense? A lot of people will start going, oh, 29 and negative 29. You know what I mean? Do the math. Okay, sweet. We found our 2 solutions. Go back to the original problem. I'm going to write it right here. I don't want to get the solutions away. Which problem was this? 23. So we're going to plug in. So I'm checking. First, I'm going to check positive 29. So we'll put in our parentheses. 29 minus 2 raised to the 2/3 minus 4 equals 5. Does that work? Type it in your calculator this side. Go. You get 5. So 5 equals 5. So that is not extraneous, so we keep it. Let's check negative 25. So we'll put in for x, negative 25 minus 2 raised to the 2/3 minus 4 equals 5. Check it. 5 equals 5. Sweet. So neither of them are extraneous. So let's pretend like one of them didn't work. We would just throw that solution out, put a cross through it, and keep that, or whatever. Do you get what I'm saying? If they both didn't work, we would say no solution. Does everybody see how that works? Like I said, we will have extraneous solutions. We just haven't got to any ones that are super difficult yet. Okay, so practice some in that section, and then we'll get to the more advanced ones. I don't want you to not be able to do story problems because they're really easy. So just watch this one. It says, the formula, this is on your worksheet 25. It says, the formula is this, relates perimeter in units of a square to its area. What is the area of the square window shown below? If this, so it gives us the perimeter. So shouldn't we put that in for P? So we have 24 equals 4 square roots of A. It says, what is the area? So aren't we just solving for A? So do you see how this is literally no different than what we just did? It's just written as a story problem. So we're not going to let story problems throw us off. Divide by 4. 6 equals the square root of A. Then we would square both sides. 36 equals A. So you'd say A is 36. So don't let story problems throw you off. Okay, let's go to 29. Here we go. First one where we're going to have a quadratic involved. So everybody watch and comprehend it and sink it in. So your first step is isolate the radical. That is always your goal, no matter what. So look at our radical. Is it completely alone on one side of the equation? Yes. Now you will undo the radical. So what would we do? What does a square root? Square both sides. Okay, good. Now I'm squaring all of that, correct? So I gotta put parentheses. I'm squaring both sides of the equation. Now look. Root cancels out with power. So we have x plus 1 equals, is it appropriate to just square that, square that? No, isn't that breaking the forbidden rule, guys? That answer should be like, heck no. We know that, right? So what we have is x minus 1 squared. So now you'd say, okay, I have lots of x's still, correct? So how am I going to solve this? Well, we're going to need to multiply it out. So we have x plus 1 equals, this is really x minus 1 times x minus 1. So we have x plus 1 equals, let's distribute, x squared minus 1x minus 1x plus 1. So what we have is x plus 1 equals x squared minus 2x plus 1. Now you'd say to yourself, how do I solve this? Well, it's a quadratic, correct? How do we solve quadratics? There's only 2 different ways when you have a middle term. Get it equal to 0. Solve by factoring your quadratic formula, correct? That is the only way. So let's get it set equal to 0. So my first step is I'm going to bring these over because I want to keep x squared positive. Subtract x, subtract x. 1 is equal to x squared minus 3x plus 1, correct? Now what are we going to do to get 1 along? To get it equal to 0, subtract 1. Are we all following? 0 is equal to x squared minus 3x. So you'd say to yourself, how do I solve this quadratic? Let's solve it by factoring. All of our quadratics are going to come out factorable. Does everybody understand? So 0 is equal to what's in common? So we'll factor out an x. Left would be x minus 3. How do we solve quadratics that are, well, now we've got it down to its linear factors. What do we do next? Good. Cassandra says, put each of them equal to 0. X equals 0, x minus 3 equals 0, and solve for x. X equals 0 is a solution, correct? Yes. got 3, x equals 3. There's our two solutions as far as we know. So let's check them to see if they're extraneous. Go back to the original problem. We have the square, so I'm checking 0. Everybody back to the original. So we have square root of 0 plus 1 equals 0 minus 1. True? Is that what I'm looking at? So isn't that the square root of 1 equals negative 1? 0 minus 1. What's the square root of 1? Does 1 equal negative 1? No. So that's an extraneous solution. So we would just cross it out. Nope, the square root of 1, so we're just simplifying right now. So square root of 1 is just 1. We're not solving, we're just simplifying, and so we just go with the primary root, it's called, if that makes sense. So we would say nope, let's check 3. So we're checking 3, square root of 3 plus 1, does that equal 3 minus 1? So isn't that the square root of 4? Equals 2? 2 equals 2. So check. X equals 3 is our only solution. Okay. Number 31. Your first step at looking at 31 is to say, I need to get the radical all by itself. So let's rewrite this as a radical. Isn't this the only piece that's a radical? That's the square root of x plus 7 to the first power, correct? And that equals x minus 5. So our first step is isolate the radical, and the radical is isolated. So now we got to undo the radical. We're going to square both sides. Root cancels out with power. X plus 7 equals, oh, we can't break the forbidden rule. Okay, good. X minus 5 times x minus 5, correct? So x plus 7 equals, can I just distribute this very quickly, everybody? X squared minus 5x will be minus 10x, correct? Plus 25. Now you'd say, I have a quadratic. How do I solve quadratics? We get it equal to 0 and solve by factoring. So watch, I'm going to subtract x and subtract 7 all in the same step. So that side's 0. 0 equals x squared minus 11x plus, right, plus 18. So now you say, okay, I have a quadratic, I'm going to solve by factoring. Well, multiplies to be 18, and adds up to be negative 11. 9 times 2, negative, negative, right? So this piece can quick factor, and they'll quick factor x minus 9, x minus 2. So x equals 9, x equals 2. So now we would check it. Everybody, you really do need to check it. This is problem number 31. So just look back at your problem so I don't have to scroll back up. Checking 9. So we have this, we have parentheses, 9 plus 7 to the 1/2. Does that equal 9 minus 5? So that is 16 to the 1/2. You could just type that part into your calculator, equals 4. So that's 4 equals 4. So that one gets to stay. Let's check 2. Plugging in 2. So we would have 2 plus 7 to the 1/2. Does that equal 2 minus 5? Type that in. That's 3 on this side, and on this side we get negative 3. Is that true? Nope, so that's an extraneous solution. You guys feel pretty good about that one? Okay, awesome. Okay, let's look at this one. What's my first step? Isolate the radical. Subtract 6, subtract 6. Square root of x equals x minus 6. My next step is to square both sides, correct? Square, square. Root cancels out with power. X is equal to, don't we need to double distribute? So that will become x squared minus 6x is negative 12x, and then negative 6 times negative 6 is plus 36. I'm confident that if you needed to write that out and do it, you could do it. So that's why I'm going so fast. Now it's a quadratic, we need it set equal to 0. So shouldn't I subtract x? 0 equals x squared minus 13x plus 36. So you'd say what multiplies to be 36 and adds up to be negative 13. Isn't it? Well, 6 and 6 would be 12, so those must not be it. 9 times 4. Yep, negative, negative, right? So this factors to be x minus 9, x minus 4. So we get x is equal to 9, x is equal to 4. Then I'm going to tell you the answer. So number 34, I'm just going to tell you, because you guys get how to check it. Yeah. X equals 9 was the only solution. 4 came out extraneous. Okay. What I'm going to have you do, okay. Would you guys know how to do this one without me telling you? You cube both sides, correct? And then solve. And, okay, so do 29 to 38 and 40. These are going to be very similar to the examples I just did. Ready, go. Everybody up here, look at 42 with me. Watch how easy ones like this are. Notice, we have two radicals here, but don't let that frighten you. The first step is isolate the radical. So what our goal is to get a radical, only one radical on each side of the equation. You got to isolate the radical. So let's bring this radical over here. Everybody watching. So we're going to add the square root of 5x plus 2 to both sides of the equation. So now what we have on this side is the square root of 7x minus 6 equals the square root of 5x plus 2. Now, what are we going to do to undo the square root? Square both sides of the equation. Root cancels out with power. We have 7x minus 6 on this side. Oh, nice. Root cancels out with power. We have 5x plus 2. And now we have a very pretty linear equation to solve, right? Combine our x's using algebra, so we'd subtract 5x. That's 2x minus 6 equals 2, correct? So we'd add 6. 2x equals 8. So x equals 4, and we would check it. So x equals 4 works. We would check it by plugging it back in, and when we do, we should get 0. So right now you can do 41, 43, 47, 50, 46, and 44. Everybody listen. Function operations is literally adding, subtracting, multiplying, and dividing dividing polynomials. Don't we already know how to do all that? So it's no different. It's just different notation. So everybody look at the top. This reads, we have a function, so we have two different functions. Everybody, function f of x and a function g of x. Is everybody watching? We have a function f of x and a function g of x. This is saying, this literally just reads f plus g, and they're both functions of x. So we literally could rewrite it as f of x plus g of x, and you're just adding the two functions together. Does everybody see how easy it is? Yeah? Are we paying attention to notation? Because I know when people don't pay attention to notation because they say, well, what's this x being multiplied in front? No, this is f plus g. They're both functions of x. That's just f of x plus g of x. Does everybody understand? F minus g of x just means we have a function f. We're subtracting it from function g. They're both functions of x. So f of x minus g of x. I put a red flag because subtraction is the most missed problem on the test, right? We've all talked about that. Subtracting polynomials, you got to distribute the negative. F times g of x, f of x times g of x. F divided by g of x is literally f of x divided by g of x. Now, keep in mind, we just did these. You would simplify them. We know that the bottom cannot be 0, correct? Right? The bottom of a fraction cannot be 0, so we'd say that function, g of x, cannot be 0. Everybody good? So division has restrictions. Here we go. So look at problem on your paper. This is problem number 1. Here we go. So given f of x is 4x minus 1 and g of x is 2x squared plus 3, we're doing these things. It's on your worksheet. So it says, what's f plus g of x? That's literally just f of x plus g of x. That's just adding the functions. So 4x minus 1 plus g of x. 2x squared plus 3. And with addition, don't we just combine like terms? That easy. 2x squared, no other x squared. 4x, no other x's, plus 4x. Is everybody following me? And then 3 minus 1 is plus 2. And we put it in standard form. Everybody good? Okay, let's do another one. Now we're doing f minus g of x. So that's literally f of x subtract g of x. So f of x is this. So we're going to have parentheses, 4x minus 1. We're subtracting g of x, which is 2x squared plus 3. Subtraction is the most missed problem on the test because people don't distribute the negative. This is not multiplication. This is just combining like terms. So don't we know that we've got to distribute the negative? Negative 2x squared minus 3, correct? Now we're just combining like terms. Negative 2x squared, no other x squareds. Negative 2x squared. Positive 4x, still positive 4x, correct? Negative 1 minus 3. Negative 4, and we're done. Does everybody see how easy this is? Well, that's simplified, right? Combining like terms. We're not solving, so it isn't divided by 2. Does that make sense? Like, we're not this is a simplified answer. Like, we don't need to factor it out and do anything with it, because that'd be solving it. Does that make sense? Okay, so for f times g of x, so that's f of x multiplied to g of x. You always use parentheses, guys, when doing this. So f of x is 4x minus 1. We're multiplying it to g of x, which is 2x squared plus 3. So let's double distribute in this problem, which we know, multiplying two binomials, 4x times 2x squared is 8x cubed. Let's be advanced thinkers and not mess up on little things that we shouldn't be messing up on at this point. 4x times positive 3 is plus 12x. Negative 1 times 2x squared is negative 2x squared. Negative 1 times positive 3 is negative 3. Your last step is to put it in standard form and combine like terms. 8x cubed, no other x cubes. Minus 2x squared plus 12x minus 3. Okay, moving on. Now notice, in number 3, it's g minus f of x. So really, this means g of x subtracted from f of x. That is not the same as f minus g. Does everybody see? G minus f. So let's put it in parentheses. This, 2x squared plus 3, we're subtracting f of x, which is 4x minus 1. So subtraction is the most missed problem because people don't distribute in the negative. But you're not going to be those people. Negative 4x plus 1. And now aren't we just combining like terms? I always see people do weird things here. Then they like start multiplying. Just subtraction, you're just combining like terms. 2x squared, no other x squareds. Negative 4x, no other x's. 3 plus 1, 4. And we're done. We're just combining like terms. We distributed the negative, it became plus 1. 3 plus 1 is 4. Right, everybody? What? We're about to get there, sorry. So now let's do f divided by g of x. This is supposed to be like that. F divided by g of x. So that literally means f of x divided by g of x. So f of x goes on top, so that's 4x minus 1 divided by g of x. G of x is 2x squared plus 3. Now you'd say to yourself, that is my answer, as long as it doesn't simplify. Didn't we just learn how to simplify rationals in the last unit? If it's factors, we factor it and divide out exact factors. Look at the top. Does anything factor? Nope. And the bottom? No. Does everybody see that? So it doesn't simplify. So we're done, except for we would just say, okay, so we do know that that's our answer, but our bottom cannot be 0. So 2x squared plus 3 cannot equal 0. True? So solve for x. Subtract 3, 2x squared equals negative 3. Next step, divide by 2, right? X squared equals negative 3 halves, then we'll square root both sides, correct? Now, square root of a negative is I, correct? So we're dealing with real numbers here, so there's no restriction here, because this is never going to be negative. Never going to be 0. Does that make sense? We have i's. So you could say x cannot equal I square roots of 3 over 2, which we're not going to ever have that, so you don't need to put it. Does that make sense? So there's no restriction. Yeah, that is true, but we're not dealing with i's. We're dealing with real numbers only. So if you put that, it's unnecessary because it's never going to be I. We're dealing with real numbers. Nothing. There's no restriction. The bottom is good. No, you don't even need to write anything. That's our answer. Is the bottom ever going to be 0? No. So it's never going to be undefined. That's what I'm saying. Does that make sense? Okay, so let's go do now the this one. G divided by f. So what's G? 2x squared plus 3 divided by f, 4x minus 1. Now we know it doesn't simplify because nothing factors. So now we'd say that is our answer, but when is it not our answer? When it's undefined, correct? We can't divide by 0, so you'd say 4x minus 1 equals 0, cannot equal 0. Solve for x. Add 1, add 1. 4x equals 1, correct? Divide by 4, divide by 4. So x cannot equal 1/4, correct? This is just like what we just did in the last unit. We simplified and restricted. You guys all get that we're not doing anything different than we just tested on. So we say that's our answer as long as x does not equal 1/4. This is no different than the unit we just learned. Everybody good? You only have to do that with division though. Okay, awesome. Go to page 3 of the worksheet. So let's do 1a. So given these three functions on your worksheet, you're on page 3. It says find f minus g of x and f minus g of 3. So first of all, I want you to do f minus g of x. Go. What did you get? Shout it out. X squared minus 2x plus 2. Does everybody get that? If not, you forgot to distribute your negatives. Okay? So that is our answer. Now B says, what's f minus g of 3? So now instead, notice, instead of f minus g of x, it wants f minus g of, instead of x, 3. So when we just take that and plug in 3, what's my function at 3, correct? That's how we do that. So now plug in 3 into f minus g of x. So that would be 3. Does everybody see how instead of an x, there's a 3? Okay, so 3 squared minus 2 times 3 plus 2. So that's 9 minus 6 plus 2. So that is, yep, 5. So f minus g of 3 is 5. Does everybody see how that works? So this is what you do. If in the problem I ever gave you and started out with this, and I said, find f minus g of 3. What you would do is do f minus g of x and then plug in 3. Does everybody see how that works? Okay. If I started out by saying what's f minus g of 3, you just do f minus g of x, subtract the function, plug in 3. Does that make sense? Okay, awesome. Hey, you guys go for that one. Go.